For the third problem of the midterm, we have an inclined gate of 2-meter width and negligible weight, but we have two fluids, water and carbon tetrachloride, and we're given the specific gravity of the carbon tetrachloride. At the same time, though, we have a concrete block with a known specific gravity immersed in water. So we're trying to find the volume of that block in order to keep the gate at the position shown. And as with a lot of problems that we've done before, we're also given a hint of use the moment balance about the hinge. So the first thing we have to do is we're not given a specific weight, and we know we're going to need it for water. So let's take 9810 newtons per cubic meters. And because we're going to take the moment balance about the hinge, we need the forces that are acting on the gate. And first we've got the force from water, the pressure force from the carbon tetrachloride, but then we also get the forces on the concrete block, which is its weight, but also the buoyant force. So we've got, in essence, 4 forces, or 3 if you just take the balance of these, the 2 forces. So let's start out with the pressure force from water. And for that, because we don't have a curved surface, we can use the formula we covered many times, which is the specific weight of the water times the distance to the center of gravity on the water side times the area where that force is applied. And the distance to the center of gravity is just at the half point of this distance, right? So we've got, and I'm gonna not include units here just for brevity's sake, but we've got 9810 and then 3/2. For the area now, we've got the 2 meters in width, and we have this distance here, which we have the 3 meters on that side. We have the angle, so we can express this hypotenuse of that triangle as 3/sin 60. So that will give us 101,948 newtons. Because we're going to use a moment balance, we also need the center of action of the line of action, the center of pressure for the pressure force of the water. And from our typical shapes, this is a rectangular, and we're going to use the moment of inertia approach, which says that YCP for water is equal to IXX, and then the sine of that angle, which is 60 degrees in this case, divided by HCG WAW. Now, the IXX for a rectangular shape is given by BL cubed divided by 12. B in this case would be the 2 meters. L would be that length, which is 3/sin 60. So by combining these two, we end up with 2 meters times 3/sin 60 cubed divided by 12 times sine 60 divided by 3/2, and then the area, which we already calculated before, which is 2, and then 3/sin 60. So with some calculations, we end up with 0.77 meters. Now, this basically covers everything for the pressure force on the water side. We're going to do the exact same thing on the carbon tetrachloride side, but the only difference now is that instead of those 3 meters, we are working with the center of gravity here, which is at 2.5 meters over 2, so 125 meters. And then this length here, which we're going to use for the area calculation, is just 2.5 over sine 60. So very similar. There we got FC gamma C, which is 159, the specific weight of water, CGC, and then AC. So we have 159 times 9810, that covers the specific weight. Then we have 2.5 over 2 times 2 for the area times 2.5 over sine 60. And that gives us 112,568 newtons. Same thing with the line of action. So again, we have the exact same equation. So we got 2, which is B, and then 2.5 over sine 60 cubed, sine 60 divided by 12, and then 2.5 over 2, and then the area, which we already calculated from before, and that will give us the line of action at 0.642 meters below the center of gravity on that side. All right, so the last thing we need is the force that's on the concrete block. And for that, we have the weight of the block minus the buoyant force, right? So for the weight of the block, it's easy. We have the specific weight of the block times the volume. The buoyant force is going to act on the displaced volume, which is exactly the volume of the block since it's completely submerged. So we have the specific weight of water times V. And WB, that's 2.5, because that's the specific gravity we have for the block, times V, times the gamma W minus gamma WV. Okay, so now we have the three components for the moment balance. And let me erase these now, so we can actually look at the moment arms. So we have the pressure force. So let's say that this is the center of gravity. The pressure force is applied somewhere here. So what we're looking for is, because the force is normal to the surface, so we're just looking for that distance there in black. And that one we can get from the total distance. So I'm going to have, let's see, blue here, minus the distance all the way to the center of gravity. So let's go first of all to the blue part. So the blue part, we know it is 3 over sine 60. The red part is half of that, so 3 over 2 sine 60. And we also need that distance here. So if we have blue minus red minus that green distance, will give us the moment arm. And we're going to do the exact same thing on the other side in the carbon tetrachloride. And for the forces from the concrete block, essentially, we have this distance. So that's, we can either calculate it from this and then all these distances and then take the sine of that, or we can just get the 0.6 here plus 3 meters here and be done with it. So it's 3.6 meters. All right, so now we know everything to set up the moment balance about the hinge. So let's take them counterclockwise, and we're gonna have W minus FB times, again, the distance, the moment arm, which is that 3 meters plus 0.6, and then plus the carbon tetrachloride force. And remember there we have the 2.5 over sine 60 minus half of that to take us all the way to the center of gravity, minus the center of pressure. Because the center of pressure is, its origin is the center of gravity on the gate. And then minus the pressure force of water, and similarly we have sine 60 minus 3 over 2 sine 60 minus yCp water, and that's equal to 0. Now if we replace what we know, the yCp's, and then also the equation we got for the weight minus the buoyant force, we end up with the volume that we're looking for times 2.4. Oh, actually no, it's 2.5. 2.5 minus 1, and then 98.10 times 3.6, and that covers the weight of the block forces, plus FC, and here we have 2.5 over 2, and then the sine of 60, which is 0.86, minus the 0.642 that we calculated, minus the force of water, and then times 3, 2, and then the yCp, which is 0.77 meters. And that's equal to 0. So here we know everything. We can also substitute the values of the forces, the pressure forces. So with that, we're going to end up with a volume of 0.158 cubic meters.